Hi and welcome to this ES6 Essentials training course. My name's James and I'm going to be taking you through a complete look at all of the ES6 features so that you get a good understanding of what they are and how to use them, and so you can start using them in your own code and projects. So in this video I'm just going to give you a short introduction to the course and answer a few questions that you might have. So I'm assuming because you're following along with this course you want to know what is ES6? Well, from a technical point of view, ES6 is version 6 of the ECMAScript standard, hence where the ES comes from. And ECMAScript defines the kind of functions and features that are available for a particular language, but as far as we're concerned, ECMAScript can be interchangeable for JavaScript, as JavaScript is an implementation of the ECMAScript standard. And this version was published in 2015, so as of recording this video, it's about 4 years old. So it still feels quite new, but in terms of technology, and particular web development, 4 years is quite a long time and a lot of other things have changed since then. The good news is though, because ES6 has been around for a little while now, most of the features are standard in browsers and Node.js, so you can make use of most of the features without having to worry about browsers not understanding your code. But I will be showing you later on in the course how you can transpile your code down to previous versions of JavaScript so that older browsers can understand your code. So one of the questions you might have is, do I need to learn ES6? Can't I just learn standard JavaScript? Well, the simple answer to that is, if you are following any modern JavaScript course, such as the Junior Developer Central JavaScript Essentials course, then you're probably learning a lot of ES6 features already, as up-to-date courses will include all the up-to-date features of JavaScript. So the second part of that question might be, why do I need to learn ES6 individually? In other words, why do I need to go through this ES6 Essentials training course? Well, you might want to update your knowledge from an older version of JavaScript, so that you can make use of all the new syntax and features, but also there are quite a lot of features that are usually skipped over within a basic JavaScript course that are available with ES6, but they can really improve the style and the quality of the code that you write. So this course will not only teach you all of the basics of ES6, but we'll also look at some of the more advanced things too. So just to give you a brief summary of what we're going to be covering in the course, we're going to be looking at things like constant variables and scoping. We'll look at some of the changes that have been made to functions. We'll look at some of the new data types that have been introduced, such as template literals and symbols. And we'll also spend a bit of time looking at destructuring arrays and objects, and also modules, which make it really easy to import and export code from different files. Then some more of the advanced features we'll look at are things like generators and iterators, maps, sets, and WeakMaps and sets, and we'll take a look at some of the new built-in methods that are available with ES6, and we'll spend a good amount of time looking at promises and how they can be used to handle asynchronous code, and then finally we'll take a look at the internationalization and localization features to handle things like language and currency settings. So that's it for this short overview. Let's start the first lesson by looking at constants. So in this lesson, we're going to look at the new constants feature in ES6, and constants are simply another way of declaring variables. So you're probably familiar with using the var keyword to define variables within your code, and once you've defined those variables, you can simply access their values by referencing them by the variable name. And obviously, as the name suggests, a variable might change its value over time, so we might want to update the age variable that we've declared. And JavaScript will happily update that variable value for us, but there are some times when we've got data that we don't want to change. So for example, my name's never going to change, so instead of using the var keyword to declare the name variable, I'll set it to a constant. So a constant variable can't ever change its value, and you can think of it as kind of a safeguarding so that you can't actually accidentally update a value that you're intending never to change. So for example, if I was to set the age variable to a constant, you can see in our output on the right hand side, we get an error saying that we're trying to assign a value to a constant variable. So you can assign any type of data to a constant variable, although obviously only once, but some developers do get tripped up when dealing with objects and arrays, so let's see how they work with the constant assignment. So here I've got an array and an object set up as constant variables, and if I try and assign a new value to the array, so when I assign a new array to the array constant variable, you see I get that error message in the console again, but most of the time you're not going to be assigning a whole new array to the array variable. More likely you're going to be pushing new items onto the array, which even though we've got this set up as a constant variable, you can still do. So even though the array is a constant, you can still add and remove values to it using the functions that are available, whilst avoiding those constant assignment errors. And the same thing applies with objects. You might think because we've set it as a constant, we can't actually edit the age anymore. But even though the object is a constant, I can still access its individual properties and update them as I need to. So unless you're reassigning a whole object or a whole array to a variable, they can be defined as a constant. So when should you actually use a constant variable? Well, the simple answer is any time that you're not going to be reassigning a value to a variable anywhere else in your code, define the variable with a constant, because if you do try and accidentally update the variable, your code will fail with the constant assignment error, and you'll be able to debug your code more easily. In this lesson, we're going to look at the feature of block scoping variables and also functions in ES6. So we've defined a simple function called count to 10, which simply has a for loop that logs out the numbers from 1 to 10. So nothing too complicated about this, and it obviously works okay, but what you might not know is that the variable I that we've defined within the for loop actually leaks out into the rest of the function. So we can access it outside of the for loop, and you'll notice it now has a value of 11 because it's been iterated one more time before it's left the for loop. And that's normal JavaScript behavior before ES6 features came in. And hopefully you can see where there'd be lots of times where this might be a problem. We'd be safer if JavaScript didn't keep the reference to I after the for loop's finished, and only make it accessible inside of that for loop. And this is where ES6 block scope variables come in. And if we simply change the var keyword to the new let keyword, you can see that the variable I is now constrained inside of the block, that is the curly braces, that make up the for loop. So we looked at constant variables in the previous lesson, but for any other variables we should really be using the let keyword to ensure that they don't leak out into the function scope of where they're declared. So that's variable scope. How do we define function scope in ES6? Well, let's say for example we had another function inside of our count to 10 function, which simply multiplies a number by 2, and if we use that inside of our for loop, you can see that that function is accessible, and it does indeed multiply the value of I by 2 and then log it to the console. And of course, because that multiply function has been defined inside of our count to 10 function, it can be used anywhere within that scope, including in that bottom console log that we have. So because functions are block scoped within ES6, we could actually declare this multiply function again inside of the for loop block. So you can see now the console.log inside of the for loop is using the multiply function that's been declared within inside of that for loop block. But the final console.log, which is in the count to 10 function scope, is still using the original multiply function. So if all that code looks a little bit crazy, then don't worry, because function scope, at least in this manner, won't be something you come across in your everyday code. But it's just a reminder to take note of where you're declaring your functions, and knowing that their scope that they can be used will be restricted to whatever block they're defined in. In this lesson, we're going to talk about ES6 arrow functions. So arrow functions in ES6 are simply a shorthand way of writing traditional JavaScript functions. And they're definitely one of those things that have become very popular with modern JavaScript code, to the point where you'll very rarely see the traditional function syntax being used unless it's in older code. So you define an ES6 arrow function with opening and closing brackets, followed by an equals and then greater than sign. You then use the traditional curly braces to denote what content should be inside of that particular function. And then you can write any valid JavaScript code in there, including returning a response from the function. So let's convert this example getRandomNumber function from an old ES5 syntax into the new ES6 arrow syntax. So the first thing I'll do is remove the function keyword, and then we'll put the equals and greater than sign. And that's all we really need to do to convert an old ES5 function into a new ES6 arrow function. Of course, if we have multiple parameters, we can add them into the brackets when we define the function. But if we only have one parameter to the function, we can actually remove those brackets completely, making the arrow function even shorter to write. And one final thing that you can do with arrow functions, if you have a short function that just returns a value that fits on one line of code, for example, you can make your arrow function even shorter by removing the return keyword and also the curly braces around it. This is known as an implicit return, as you're not actually typing the return keyword, but JavaScript and ES6 will know that you actually want to return this value from the function without having to have the return and curly braces syntax. And again, this is something you'll see in a lot of modern code when you've got lots of short functions that you need to implement. A lot of developers like to use the implicit return because it makes the code a bit neater. This isn't the only changes that have been made to functions in ES6, and in the next lesson we'll look at some extended parameter handling techniques. In this tutorial, we're going to look at some of the new features that ES6 has introduced to functions, including default values and the REST operator. So I have a simple function called sayHi that takes 3 names and then prints out a greeting, which is actually set as the final parameter to the function call. So we can assign any of the arguments to the function a default value. So if we were to remove the greeting value that's supplied when we call the sayHi function, you'll see in the output on the right hand side that the greeting argument has been set as undefined. So what we can do when we define our sayHi function is assign a default value to the greeting argument. So now when we don't pass a string for the greeting parameter to the sayHi function, the default value that we specify in the function definition will be used instead. This can also help deal with undefined values if they're passed to your function. Say we have a variable that's set in some other part of the code and it gets an undefined value. If this is then passed to the sayHi function, we can catch those undefined values from flowing through into the function by setting a default value on the name3 argument. So that's quite a common technique for dealing with undefined values that are accidentally passed to the functions that you're calling. So the second thing we're going to look at in this tutorial is the REST operator, and the REST operator is a convenient way for dealing with multiple parameters that are passed to your functions. So having to specify the name1, name2 and name3 variables when we define our function is a little bit restrictive because our sayHi function is always going to be expecting at least 3 names to log out to the console. And of course you saw a moment ago that if any of those variables are undefined, the output that we get isn't quite what we're expecting. So we could pass all of these names into the function as an array, but the REST operator will allow us to keep this same structure when calling the function, but access any variable length arguments as an array inside of our function. So we define the REST operator with 3 dots, or periods, and you'll notice we get an error straight away in our console saying the REST parameter must be the last one in our function definition. So now if we just log the names argument to the console, you'll see it consists of the last 3 parameters that were passed to the sayHi function call. And of course we'll probably want to move the greeting text to the start of the function. And of course, now we have an array of names inside of our sayHi function, we can just use a loop to log them to the console. And we're able to add new names as more arguments to the sayHi function call. So the REST operator and this technique is really useful when you've got a variable list of arguments that you want to deal with within your function, but you don't necessarily want to bundle those up into an array to pass them into the function. In this tutorial, we're going to talk about the spread operator, which has the same syntax as the REST operator, but is just used in different parts of your code. So the spread operator can be used with both arrays and objects, and you can kind of think of it as a tool to separate objects and arrays into their individual values. So we call the spread operator with 3 dots or periods, and if I use it on the array1 variable, you'll see I can get the separate values that are stored inside the array rather than just the actual array itself. So there are a few practical uses for using the spread operator with arrays. Let's say for example I had a really simple function that adds 3 numbers together. If I was to call this with one of those array variables, you'll see the output that we get isn't quite what we were expecting. But if we add the spread operator before the array variable, you can see that it separates each of the values that are in the array and assign them to each of the arguments to the add function. So that's one example, but a really common use case for the spread operator is to merge two arrays together. So let's say I want to add the contents of array 1 and array 2 together. You might do something like this, but you're actually creating a new array and adding the arrays inside of that, and ending up with a nested array structure. So you can merge the two arrays together using the array.concat function, but the spread operator gives us a bit of a shortcut to doing this. And of course, there's nothing stopping us from adding more values to the array as well. So that's just a couple of examples of using the spread operator with arrays. Let's have a look at how you might use it with an object. So if we wanted to merge these two objects together, we could use the object.assign function, but we can also use the spread operator in the same way that we merge the arrays together, but this time with the objects. And finally, you can also use the spread operator with objects to create a shallow copy of an original object. For example, if we change the value of the name property in object 1, we can create a clone of object 1 before the change happens, obviously, if we want to duplicate the original object. So that is something that can be done with object.assign as well, but as you can see, using the spread operator makes that code a little bit shorter and also easier to read. In this tutorial, we're going to look at template literals and how you can use them to deal with string concatenation and variable or expression interpolation into existing strings. So template literals are just another way of defining a string within JavaScript. So instead of using single or double quotes, to define a template literal, we actually use the backtick. And as with the single and double quotes, you need to have an opening and closing backtick for the template literal string. So the first thing that you can do with a template literal is use it just as a normal string by entering some text into it. And one of the nice things about template literals is any white space that you put inside it is actually preserved and is shown when the template literal is reused. So this means we can have multi-line template literals, which is something that you can't do with single or double quotes. The other main use for template literals is for variable or expression replacement within a string, sometimes known as string interpolation. So say for example we had a variable that held a particular value. We can then access the value of that variable inside our template literal by using a $ and curly braces syntax. So if we were to use this to rewrite the createURL function that's been defined above, we could get rid of those messy plus operators by replacing the whole line with a template literal. So you can see by using that template literal, it's a lot easier to read and we don't need all of those plus operators to concatenate the string together to give us the URL. And finally, when using this string interpolation method, you aren't restricted to just using variables. Any expression in JavaScript can be used inside of the curly braces. So you could do some simple arithmetic, or you could do something more complicated and include things like ternary operators to make the output of your template literal conditional. For example, you can create any expression that you like. For example, here I'm just getting the hours of the current day and comparing it to see if it's less than 12 to display either AM or PM, depending on whether that expression is true or false. And of course, you can keep on nesting these expressions as well to create more complex
conditions for your template literals, although the best advice is to probably keep it simple to maintain the readability of your code. So that's just a few examples of how you can use template literals to work with multi-line strings and also to work with string interpolation with variables and expressions. So another new ES6 feature closely related to template literals are tagged templates. And you can think of a tagged template as a function that takes in a mix of strings and variables and then formats them and returns them based on some conditions or rules that you apply. So in this example, I've created a function called greeting that has two parameters, strings and name, and strings will actually be an array of all the blocks of strings that we provide to our tagged template, and the name parameter is a variable it will pass in via the dollar and curly braces syntax. So to call a tag template, you simply reference the tag template name and then directly pass a template literal straight after it. And you'll notice in the output that we only get the first part of the template literal that we pass to the tag template of greeting. And that's because the second bit of text, the nice to meet you, is in the next part of the strings array, which we haven't actually used in our tag template. So whilst this is useful to play around with the format of a template literal, it's not really doing much more than we could do by simply rearranging some of the values in the template literal itself. The real power with a tag template is when you've got some more complex logic that you need to apply to the template before you return a completed string. So here you can see a more complex example where we're doing some logic depending on what time of the day it is. And you can also see we're skipping part of the original template literal that's passed to the greeting tag template at the start of the string, which is useful if you've got your data from another source and you want to skip part of the information and replace it with your own custom templating. So that's just one example of tag templates, and they can really help you simplify complex logic within your template literals. Another new feature in ES6 is the ability to work with extended literals, such as the numeric binary and octal literals, and also some more support for Unicode characters. So there has been support to work with binary numbers in previous versions of JavaScript. For example, if you wanted to get the binary equivalent of an integer, you can call a toString function on the number, and by passing in 2, you get the base 2 value, in other words binary, representation of 404. But as the function name suggests, it will convert it to a string, which might not be what we want to do. So with ES6, we can use binary literals to represent a binary number while still preserving its data type. We can also do the same thing for octal numbers if we need to as well. We just need to substitute the B at the start of the number with an O. So those are some new features for working with numbers in ES6, but there's also some more support for Unicode, which is useful for when you're working with languages that have extended character sets or even emojis. So we can see that the smiley face emoji has a length of 2, and that's because it's made up of 2 Unicode characters. And you can access the 2 values of those Unicode characters by using the code point at function and specifying 0 and 1 to access the individual items, which you can then use in your code to generate emojis or other symbols using the string.fromChar code function. So that's just a few examples of the extended support for Unicode and binary and octal literals in ES6. In this tutorial, we're going to look at some of the enhanced object properties that are available within ES6. So there are a few new features available for objects in ES6, including the property shorthand, computed property names, and also method properties. So we're going to take a look at those three things in this tutorial, and we'll start off by looking at the property shorthand, which is a really simple way of, when you're constructing objects, to miss out property names if you've got variables that have the same name. So for example, let's say we were going to send a username and password to an authorization endpoint. We might construct an object with that username and password to send by some method like the fetch API, for example. So here we already have the username and the password stored in variables with the same name, and when we're creating the auth object, we're literally just repeating ourselves by saying we have a property called username whose value is stored in the variable username. So the ES6 property shorthand allows us to remove the property name and use the variable name for the property name instead. And as you can see on the output on the right hand side, the auth object still has the username and password properties with the values that we provided in the variables. So this is a really useful tool to make the construction of your object shorter, but you'll also find that it's useful to help you come up with names for your variables, because if they match the property names that you're going to be creating in your objects, you can make use of the property shorthand to make your code neater. So another feature that you can make use of with objects in ES6 is the ability to create computed property names, which simply means you can create the property name for an object based on some variable or expression or even a function. So you can see in the auth object now, we're actually creating a new property which isn't called departments, it's actually taking the value that's stored in the department variable and using that as the property name. So this is really powerful when you don't know what the properties of the object that you're creating are going to be, and you can even loop through an array of values to create these properties, dynamically creating their names based on some expression that you define. The final feature we'll look at in this tutorial is the ability to add method properties to objects. And there's nothing too special about the method property syntax. It's just another shorthand that allows us to set up a new property on the object and assign it a function. So essentially this is more of a stylistic thing, because we could do the same thing by creating a property called resetPassword and assigning a function to that property. But method properties follow the same sort of style that you might find in other languages, like C# or Java for example, and they become really useful when you start working with classes, as it helps to separate all of the functions that you're creating on your class into tidy blocks of code. And we'll come back to method properties when we go over classes in a few lessons' time. So those are a few improvements to objects that have been added in ES6. In this tutorial, we're going to look at the new ES6 destructuring feature and how you can use it to work with arrays and also objects. So destructuring is basically breaking down a more complex data structure like an array or an object into its component primitives and then saving them into variables. So let's dive in with an example of how we could destructure an array. So here I have an array of strings that I'll destructure into component variables. So the syntax might look a bit backwards, but we take the name of the array, in this case languages, and put it on the right hand side of an assignment operator, with the left hand side having the variable names that we want to destructure the array into. So as you can see from the output on the right hand side, the variable A has the first string of JavaScript, B has the second string of Python, and so on and so on. So when destructuring an array, you don't need to specify all of the positions, but obviously you'll only be able to work with the variables that you do destructure from the original array. The other thing you can do is skip out positions in the array by not specifying the name and just adding an additional comma into the destructuring statement. And you can also assign default values if you're not sure whether a position is going to be filled. So whilst you can destructure any length of array, it's more common to destructure a smaller array that has a fixed size, or for example when you only need to match the first few values. Object destructuring, on the other hand, is more common. So let's now take a look at how object destructuring works with ES6. So taking a simple object like this, we can destructure it to its component values, but we need to make sure that the variable names that we define match the properties within the object. So you can see the syntax is very similar to destructuring an array, except this time we use the curly braces, and we now have all of those properties extracted into local variables, except for the unknown variable, which has no value as that doesn't actually exist in the original object. So again, we can assign default values if we need to. And we can skip out some properties if we don't need them. So one little tip is that you can actually extract one value from an object and save it in a local variable, while saving the rest of the properties into a new object. So this is really useful if we want to throw away one property in the object. For example, we don't need to know whether the user is an admin, but we want to use the rest of the object in another part of our code, like in this example when we might be using the username and password to log in. So with this rather crude login function, we could supply the rest of object variable that just has the username and password stored in it. But there's one final thing that we can do with object destructuring, which will make this code a lot neater, and that is to use a destructuring assignment called parameter context matching, where we basically destructure the parameter that's been passed to the function directly inside the function call. So here you can see the object has been destructured where previously there was just a single parameter, which sets them up as local variables within the function scope, so we don't have to access them on the object via their property names. You can also do the same parameter context matching with arrays, but that's a little bit less common, again because of the positioning of the items in the array may cause some unpredictability in your code. So there you have some examples of destructuring arrays and objects using the ES6 Destructuring Assignment. In this tutorial, we're going to look at modules in ES6 and how you can use them to write separate bits of code that can be written in one file and then used in another. So historically, JavaScript has had a few different ways that it's dealt with code in different files, and how you can access variables and also call functions that are stored in one file in another, whilst also avoiding duplicate names for those variables and functions. And ES6 introduced two new keywords, the import and export keywords, which allow you to export the functions and variables from one file and then import them and use them in another. So let's take a look at what that looks like. So a basic module might look like this, where we're defining a function and then using the export keyword to make it available to other files. Of course, we might have multiple functions defined and export all of them. But when using our import statements in our main.js file, we only need to import the functions that we want to make use of within that particular file. So if we were to go ahead and run the main.js file now, we actually get an error in our console, and that's because at the time of recording this, even the most latest up-to-date versions of Node don't yet support the ES6 module features and the import and export keywords. So hopefully this is something that will be updated in later versions, but for now we need to use some bundling software to actually get the ES6 module feature to work. And there are several different options available to you for doing this bundling process, but for this example I'm going to use Parcel, which is a really simple zero configuration piece of software that you can install with npm. So if you install Parcel with the -g modifier, you can use it globally on your terminal. So now we can actually bundle up our code together to see that module working. And we do that with the Parcel build command. And you can see that creates a new file in a folder called dist for distribution. So now if we run that code, you'll see we get the value of 8 being logged out to the console, which is the result of the sum function from the maths module that we created. So if you're not using Node and you're working with the browser, you can still use Parcel to do your bundling. So this time I've loaded the main.js file into a simple HTML template, and using the parcel serve command, I've bundled the module together and it'll be running on that local host address. Which, if we look in our console, you'll see has the result of the sum function called in our main.js file. So just before we finish, there's one final thing that you can do with modules in ES6, and that's to use a default export. So for example in our maths module, if we only wanted to export the sum function, we could do something like this where we export a default function, and then over in our import statements we simply remove the curly braces from around the function name that we're importing. And the useful thing here is that we can rename that function anything we like, and we'll continue to get the same output. So this is quite useful when you only have one thing to export from a module, which is usually the case when you're creating classes with ES6. In this tutorial, we're going to look at classes in ES6 and how you can use them to build your own objects that consist of a number of functions and variables. So I won't delve into the old way of constructing objects in JavaScript before ES6, but it's just worth pointing out that you can still use that method, and all the ES6 syntax really is a nicer and easier way of constructing new objects, otherwise known as syntactic sugar, on the existing JavaScript way of doing this. So a class is a blueprint for constructing a new object, and you'll generally base them around a particular thing. In this case, I'm going to be constructing a new user. So when an object is created from a class, a special function is called the constructor. So a constructor is simply a function that may or may not take a number of arguments, and then does some setup for our object. And this gets called when we create a new user object. And the variable names that we assign values to with the this keyword are available directly on the newly constructed user object. So in addition to the constructor, we can put any number of functions that we want within our user class. And we can call those functions on any objects that we create from this class. So these functions within the user class are known as methods, and the variable names that are assigned to the class with the this keyword are known as properties or member variables. There are also some special functions that you can set up on classes called getters and setters that allow you to either set the value of a particular member variable or return its value. But you can run into issues with naming, as you can see from the output from our console here, if you try and use a getter or setter name that is the same as one of your member variables. So it's common practice to prefix those member variables, usually with an underscore. And now we no longer have an issue with conflict of names. So you might be able to see that the setter function has a particular use in being able to set the value of a member variable directly, but really our password getter doesn't really do much other than return the password member from inside our class. But where getters are really useful is if you want to modify the value before you return it. So all of the methods that we've created inside of our user class must be called on a new user object that we've created with the new keyword. For example, we couldn't just say user.show. And this makes sense because the data inside of the show function is related to the user object that we create, but there might be times when you want to call a method that doesn't rely on information from a newly created object. For example, we might want to get a login URL, which isn't actually specific to any one user. So if we want to call this method directly from the class name, we can set it to be a static method. So anytime you don't need to rely on data from a newly created object, you can set a class method to be static, and then it's available to be used without creating a new object. So that's just a simple example of creating classes in ES6 with constructors, methods and member variables, and also getters, setters and static methods. So in the previous lesson, we looked at how to create classes in ES6. In this lesson, we're going to look at inheritance and how you can create new classes based on an existing base class. So in the previous lesson, we had this user class, which has a few methods and properties available on it. With inheritance, we can take this base class and create a new class on top of it and add some additional functionality and also override some of the existing functionality. So our constructor for the developer class looks very much like the constructor for the user class, but this time, instead of setting all the member properties on the developer class, like the username and password, with the this keyword, what we can actually do is pass the username, password and logged in parameters to the user class constructor by using the super function. So this will call a constructor in the user class, and set the username, password and logged in properties accordingly with the values that we pass in to that super function. Of course, we've got an additional parameter in our developer constructor, and that's the languages parameter, so we'll just set that as a member variable on our developer class. So you can see already that the developer class has got all of the properties of the user class, but we're adding a new one which is specific to this type of user. So along with new member variables, we can also add new methods to our new class, which if we construct a new developer, we can then call on the newly created object. And because our developer class inherits all of the functionality from the user class, we can also call any methods defined on that user class. So one of the really powerful benefits of inheritance is you can actually override methods in the base class to change their functionality. So here you can see we've overridden the show method from the user class to now just list the languages that relate to this developer. If you want to make use of the base class methods inside of your overridden methods, you can use super to reference the base class. So using a combination of the base class and overridden methods and new member variables inside of an extended class, you can really customize it depending on the needs of your code. In this tutorial, we're going to look at symbols in ES6 and how you can use them to create globally unique values. So a symbol is a new primitive data type, so very much like a string, but whereas if you compare one string to another, you can tell whether they're equal or not. A symbol can never be equal to another symbol. So symbols are really useful when you want to have a globally unique reference, say for example in an identification property in an object, and also for unique keys in objects. So we'll take a look at those examples now. So for this simple user object, we might want to create a unique reference for the ID property, and to create a new symbol, we simply use the symbol function. And optionally, you can pass a string into the function, but it has no bearing on the actual value of the symbol. It's really just for debugging purposes. So using symbols in this way isn't really correct, as if you define a symbol without saving the reference to it in a variable, you can't do any comparison later on in your code. So as we saw at the start of the video, comparing two symbols together will always result in false, and the string that you pass to the function doesn't alter that in any way, as it's only really for debugging your code. So if you do need to do comparisons with symbols, you need to make sure that first you save the reference to the symbol into a variable. Then, whenever you use your symbol, if you want to do a comparison, you can compare it to the symbol that's stored into the variable that you create. So the other use case for symbols is to create properties in objects that have the value of a symbol, and creating objects with symbols as properties actually hides the property and value from certain parts of JavaScript. As you can see in the output on the right hand side from this for loop, we get the name and ID properties, but the permission symbol is hidden. So in a similar way as using symbols as values, if we don't store the reference to the symbol in a variable, we've got no way of retrieving that property later on. So if we do save the symbol into a variable and then use it as a key in our object, we can use the reference of the symbol that's saved in the variable to access that value later on. So that's just a quick overview of symbols in ES6 and how you might use them to create unique values in your objects that can't be accessed by certain parts of JavaScript. It's probably worth saying that you can see from the output from the user object that you can still see the value that's associated with the symbol property. It's not hidden from the user's view, so you should never use symbols as a way of protecting data, like hiding passwords for example, as ultimately the data isn't protected, more so that it's just hidden from certain parts of your code. In the previous video, we looked at symbols and how you can use them to create globally unique values. And in ES6, there are some built-in symbols that have various different uses, but in this video, we're going to look at the Iterator symbol and also the new for-of loop and how you can use them together to create your own custom loops based either on a complex data structure or function. So you'll know how to do a for loop in JavaScript, as with the C-style loop that we have here, or maybe using the for each higher order function. But we're going to look at how to use the iterator symbol to create our own custom sequence. And just to highlight what you can do with this, we'll recreate the FizzBuzz challenge, which is commonly used at coding interviews. So first of all, let's create an object. And we'll create one property or method function with the iterator symbol. And inside this function, we'll just return an object that in turn has one property or method function called next. So the next function returns an object that has two properties, done and value. And this next function will get called every time our FizzBuzz object gets looped over or iterated, and as this name suggests, the done property of this object will indicate to the for loop whether we're finished or not, and value is the actual value that's going to be returned. So let's create a local variable that's going to do the counting up to 100 for us. And in our done property, we'll check to see whether the value of I is greater than or equal to 100. And if you've ever been through FizzBuzz before, you'll know there are loads of different ways to actually solve the problem, but just for brevity, I'll use a nested ternary operator to return the necessary text or number, depending on the value of I. And of course we need to remember to increment I each time next is called, which will ensure at some point the condition in the done property will actually be true and the iteration will stop. So in order to call the iterator on our FizzBuzz object, we use the new loop type that's created in ES6, which is the for-of loop. So instead of using the C-style loop, or even the for-in loop which loops through an object's properties, we use the for-of loop, which will call our custom iterator, which essentially calls the next function each time the loop goes round. And if you look at the output on the right hand side, you can see that value of I is being incremented, but displays fizz, buzz or fizzbuzz, depending on the condition that's met inside of that next function. So there's just a simple example of how you might use the iterator symbol to create your own custom sequences that can be used with the for-of loop. In this tutorial, we're going to look at generator functions in ES6 and how you can use them to create functions that can be paused and then later resumed. So in order to create a generator function, we need to use the function keyword followed by a name for the function, which includes an asterisk. And the asterisk can either go directly before the generator name or after the function keyword. So if we were to just call our generator function as it is, you'll see that it doesn't actually run any code inside the function. In fact, if we put a console.log inside the generator function, you'll see that doesn't actually get into our output because we actually need to call the next function that's available on our generator object in order to run the code that we've declared inside our function. So if you've been through the previous tutorial on the symbol iterator, you'll remember that the next function actually returns an object with a value and a done property. So our value is actually undefined, so how do we actually pass back some data from our generator function? Well, we do that with the yield keyword. So simply putting a value after the yield keyword returns that as the value property from our call to the next function. But yield also has the effect of pausing the execution of the generator function. So you'll see that that second console.log doesn't actually go to the output, and that's because the generator function is paused, waiting for another call to the next function. You can also pass in parameters to generator functions too, and even used with the yield keyword to pass it back as a value when the next function is called again. So we can also return values from our generator function to set the done property to true to indicate that the generator function has finished. But of course we need to call the next function one more time as the generator function is still paused on the second yield keyword. And you'll see by returning a value, we get that value back and the done property is now set to true. So a more concrete example of using generator functions might be something like a counter or something that's keeping track of unique IDs, but that never really has an endpoint and needs pausing after each unique value has been created. So having a while loop that's always going to evaluate to true is usually a bad thing in JavaScript as it will actually create an infinite loop. But in the case of generator functions, it's actually quite useful, especially in this example because we can keep incrementing the index value whilst we want to create more unique IDs. So that's just a simple example of how you might make use of generator functions within your code. So sets in ES6 is a way to create a group of values that can't contain duplicates. So whereas the array that we've currently got defined has a couple of duplicates in there, a set won't allow you to do this. So in order to make use of sets, we need to create a new set object. And we need to call the add function on the new set object in order to add values to it. If you do try and add a value that's already stored within the set, JavaScript will happily allow you to do that, but you'll notice in the output on the right hand side that the set only has one string that's equal to Java. So there are a couple of other functions that you can call on a set object. We can use the has function, which obviously checks whether the value that we put inside the parentheses is inside the set. We can also remove values, and you can find the number of items in a set with the size property. If you want to loop over a set, there is a for each function, or you can use the for of loop that we've seen in the last few lessons. So one thing to be aware of with sets is when you're working with objects, because a set will only remove duplicate references to objects and not actually the value of objects themselves. So you'll see if we add two identical objects to a set, they will be stored as two separate objects within the set, as the set can't distinguish between the two objects in memory. However, if the object was to be stored into a variable, the set would just add the reference to the object once, and any subsequent calls to the add function works in the same ways as the strings that we were using previously. So that's a quick overview of sets and how you might use them to keep track of a group of unique values within your code. In this tutorial, we're going to look at maps in ES6 and how you can use them to replace object literals. So maps are another type of data structure similar to sets that was introduced in ES6, and where a set is more like an array that can't have duplicate items, a map is like an object literal with a few more features. So I have this user object literal at the moment, and I'm going to recreate it with a map object instead. So let's first create a new map object. And in a similar way to sets, we can add new properties to the map using the set function. And you can see from the output on the right hand side that the user map object we've created looks very much like the original object literal. And of course there are functions available to get those values and also the size of the map. So you might be thinking, what are the differences between an object literal and a map? And one of the key differences, you can use any type of value for the key that you're setting within your map. For example, we can use an object like a date object, or we can even use our own custom objects that we create as keys. So there are a few other functions that are useful to use with maps. For example, you can loop through all of the keys in the map, like for example using the forEach function, which allows you to get every value that's been set inside of the map. There are of course ways you can do this with object literals, but you can't always rely on the order of the keys being in the same order as you define them when you create the object literal. So that, with a few other safety features of maps, makes it a cleaner alternative if you're going to be doing algorithms that are based on this data structure. In this tutorial, we're going to talk very briefly about weak sets and weak maps, and how they differ from their counterparts, the set and map objects. So first, looking at weak sets, a weak set is an implementation of a set that holds objects in a collection and will remove them from memory when they're no longer needed. So unlike a set weak set can't contain a string, a number, or any other type of primitive value. We can only store objects inside the set. So this might seem a bit restrictive, but the reason for only having objects is because JavaScript keeps track of which objects are no longer in use, and then can remove them from memory via a process called garbage collection, thereby making your code more efficient and ultimately possibly less prone to errors. So adding an object directly to a weak set like this isn't ideal because we can't actually remove the object from memory. So let's create that inside a variable instead. And so we can check if the set has the user object inside it. And when we destroy the user object by setting it to null, calling the has function again shows us that the user object has been removed from memory and also the weak set. So it's worth pointing out that if this was an array, simply setting the variable of an object to null wouldn't actually remove it from memory, which is what makes weak sets more efficient. So as you might have guessed, weak maps are exactly the same. They're the same implementation of the map data structure, but only allow you to use objects as keys. So as you can see before, trying to use a string as the key property results in an error in our output, whereas using the user object that we created allows us to set and get values from the weak map. So that's just a quick overview of weak sets and weak maps. If you just take away that you can only use objects with weak sets and maps, and that they have some built-in garbage collection that will help to clean up unused objects from memory. In this tutorial, we're going to take a quick look at typed arrays in ES6. So a typed array is very much like a normal array in JavaScript. However, they create an object which represents some underlying binary data. So if you get involved in working with network level requests to certain resources, or working with cryptography, for example, or just any other data that depends on working with binary, like working with files. So as you can see, there are various different constructors that you can call to create a typed array depending on your needs, and it's simply a matter of working out whether you need to have integer values, floating point values, and whether they need to be signed or unsigned. But other than that, the typed arrays work in very much the same way as a normal array. And you can see you can assign values and return values in much the same way that you would with a standard array. So the power of these typed arrays is when you start working with that binary data, and some of the properties that the typed arrays bring to that. For example, the int 8 array that I've created only stores values in the range of -128 to 127. So if I try and assign a value outside of that range, you can see in the output on the right hand side that the value that's been assigned into position 1 of the array has been adjusted to meet those binary rules. So that's just a brief overview of typed arrays in ES6. If you do start working with binary data within your code, you'll start to get more familiar with these typed arrays and when to use them for different purposes. In this tutorial, we're going to look at the object property assignment method, otherwise just known as object.assign, which was introduced in ES6. So the object.assign method has a few different uses, and the first being, as the name suggests, we can easily assign new properties to an existing object. So that might look a little bit long-winded just to add another property to the request template object, because we could have either used bracket or dot notation to add new properties to that object, but where this kind of syntax comes in useful is when you want to merge two objects together. So this means you can add multiple properties at once, or just not worry about the structure too much of the second object, and just know that these new properties will be merged into the original object. The object.assign function does actually return the object, but you can see that we've actually changed the original request template object, which might not have been our intention. So the way around this is to use an empty object as the first parameter to object.assign and save the result into a new variable. So here you can see the request template object still has the original details, whereas the custom request variable is a brand new variable that includes the details object as well. So this also highlights the second really useful use case for the object.assign method, and that is for copying objects. So for example, if we remove the second object, the details object, from the object.assign method, you can see the request template object and also the custom request object are completely identical. So this is really useful if you want to make a copy of an object within a function or method, but don't actually want to mutate or change the original object. You have to be careful with objects that have deeply nested properties. Because as you can see, if we actually modify the value of a deeply nested property, even after it's been copied with the object.assign method, we can still affect both objects. If you do need to avoid this, you can get around it by using the json.stringify and json.parse functions, by first of all converting the original object to a string, and then storing the result of the parse function back into a new variable. But other than that, the object.assign method is really useful for making a shallow copy of objects, and also when you have to merge two objects together. In this tutorial, we're going to look at a couple of built-in array element finding methods that were introduced in ES6. So these are really simple functions, but are really useful for when you want to check if an item exists in an array in JavaScript. So the two methods are find and findIndex. So the find method asks you to return a Boolean expression, which when matched will actually return the value in the array. So using this, you can actually check for the existence of a value in an array, and the findIndex method will actually tell you at what position it's in. So because you're using a Boolean expression in the callback to the find and findIndex methods, if you're working with other type of data, you can customize it to those needs. For example, if your array just contains numbers, you can use some numerical operator comparison. And if you're working with an array of objects, you can access the object's properties as part of your expression. And when using the find method in this way, once a match has been found, you can then access the other properties of that object. So that's just a quick overview of the find and findIndex methods. You can achieve the same result with ES5 methods such as filter, but these new ES6 methods provide you with some convenience. In this tutorial, we're going to look at some of the new built-in string searching features available in ES6. So traditionally, you'd use the indexOf function to find out if a substring exists, which will give you back the position in the string where the first instance of the substring occurs, or alternatively -1 if the substring doesn't exist. So to make life simpler, in ES6 we can use the includes function, which will give us a true or false value back to indicate whether the substring is present in the string that you're calling the includes function on. You can also pass an offset to the includes function, which will skip a certain amount of characters in the string before checking for the existence of the substring. The other things we can do are to check if the string starts with a certain substring, and there's also a corresponding ends with function. You can also pass offsets to the starts with and ends with functions to actually trim parts of the string. Although for clarity of code, it's probably better to trim the original string and then just call the ends with or starts with function on the newly trimmed string. And finally, ES6 does provide one more string function, which is the repeat function. So in ES5 you'd need to use a for loop to produce a repeated string, but now we can just call the repeat function with the number of times that we want to repeat a string to create a new string. So that's the new string functions in ES6. In this tutorial, we're going to look at some of the built-in number features that were added in ES6 that are available for use on the number and math object. So the first new numerical function that's available with ES6 is quite a useful function if you want to check whether a number has actually been parsed correctly and isn't actually a not a number. And the function that we can use to test our variable, or indeed any other value, is number.isNotAnumber, which will obviously give us a false value back if we pass an actual number directly to the function, but when we call it with the variable that we defined above, you can see that the function returns a true value. So this is actually really useful if you want to test some data that's been returned from an API or indeed some user input, and you're not totally confident that the data that you'll get will actually be able to be parsed as a number. You could of course do this with some value checking, but the static isNotAnumber function provided on the number object is a convenient function to do this for us. The second function that we'll look at on the number object is probably a little bit less common to use, which is the isFinite function. So basically this function on the number object will always return true if the value that we pass into it is a finite number, which basically means any number that we pass to it other than the special infinity value, which when we pass that to the isFinite function gives us a false value back. So again, probably not a function that you're going to be using regularly, but just useful to know that it is available if you need it. The other two functions that were introduced are actually on the math object, and the first is for truncating a decimal number, which, as you can see in the result on the right hand side, actually just removes the fractional part of our decimal number, and it doesn't matter what we put in there, they will always be removed and the whole number will be returned. So you might think this does exactly the same thing as the math.floor function that's already available in JavaScript. But let's see how the result differs if we provide a negative value. And that's because although the math.floor function does round down to the lowest part of the whole number, in this particular instance, negative 43 is actually closer than negative 42, so the math.floor function rounds it down to minus 43. So if you absolutely want to be sure that you're removing the fractional part of a number, you can trust that the math.trunc function will do this for any type of number. So the final function we'll look at is the math.sign function, which, as the name suggests, will indicate whether a number is negative or positive. So for a negative number, we get a result of negative 1, and for a positive number, we get a value of 1, and if we pass a value of 0, the value returned by the math.sign function is 0. So that's just a quick overview of the number functions that were introduced into ES6, some quite useful and some not so useful, but knowing about them will help you if you need to use them in your code. So along with the new number functions that we saw in the previous video, ES6 introduced some internationalization features via an internationalization object that allows you to format a number based on a geographical location. So to make use of this, you just need to construct a new number formatter and then specify a country code as a string, for example for the US, which can then be used to format a number when being output to the console or displayed at some part of your web application. So you can see the difference in the output on the right hand side, whereas just logging number to the console gives us the value that we stored inside the variable, calling the format function with the number on the formatter object actually returns a nicely formatted string, which is separated by commas to denote the units, according to how that would appear for US users. So just to contrast that, if we were to choose a different country, say Germany, you can see the number is now separated by periods for the units, and the decimal is represented by a comma. We can even format this number further if we pass in another object with a few properties. So the object has a property style which we set as currency, and a currency property which we set as the currency code for the US. And you can see on the output on the right hand side that we now have a dollar symbol at the start of our formatted number. And again, just to contrast that with a different country, you can see how the currency symbol will vary depending on those internationalization settings for which country you're looking at. There's also another style which will handle percentages, or of course you can just set the style as decimal, which is the default behavior. So there we have a nice way of formatting numbers with the internationalization object within ES6. So we saw in the previous video how ES6 introduced the internationalization object, which allows you to format numbers based on a geographical location, such as being in the US, Germany, or the UK. And the formatter object that we create allows us to format our number like a currency or a percentage, but we might also want to format our date strings that we work with in JavaScript. And luckily, along with the number formatting, we can also create a new datetime format object and specify a certain localization. So as with the number formatter, we create a new object and store it into a variable, and then call a format function on that variable and pass in a date object. So as you can see from the output on the right hand side, the string that we get back is formatted to how a user in the US would expect to see today's date. But if we change our localization to, say, the UK, you'll see the month and the day value flip over, as here in the UK, the day of the month is actually the first value that we have, or at least the first value that we're used to seeing when dealing with dates. Of course, other countries have other conventions for formatting their dates. For example, looking at Germany again, you can see the separator that's used is a period instead of a forward slash. So the internationalization object provides these datetime formatting functions to provide a convenient way of formatting date times depending on a particular localization. In this tutorial, we're going to look at the proxy object that was introduced in ES6. So a proxy in JavaScript is a way of intercepting and creating custom behavior for fundamental operations on objects. So if you think about when you look up a property of an object or assign it a value, you can put a custom function in front of those operations to modify its behavior. So let's imagine you had an object with some user data in it. You can assign a proxy to this object by creating a new proxy object and passing the user variable in as the first argument. So just doing this on its own won't have any effect on the lookup or assignment of properties to the user object, but you can create this custom behavior by passing in a function in as the second argument when creating a new proxy. So inside our handler variable, we need to set up something called a trap, which recognizes the behavior that we're performing on the user object and change it accordingly. For example, if we wanted to modify the behavior of when we access a property on the object, we would want to set up the get trap on the handler object. So you can see now when we try and access the name property of the proxied user object, it will simply return the string nothing here. And the same would be for any property that we try and access on that user object, including the password or a non-existent property. So that's just an example of using the get trap in a proxy, but realistically we might want to only affect some properties and modify the way they're displayed when the property is accessed. So here we've just modified the get trap to check the name of the property that we're trying to access, and if that's equal to password, we'll just return a string that's repeated for as long as the value of the password property is. If not, we'll just actually return the value stored in the object with that property name. So the other thing we can do is set up a set trap, which, as the name suggests, will be called when we try and assign a value to any property within our proxied user object. And this time we've actually got access to the overall object, the property that we're setting, and the value that's been supplied. So with this information we could set up some simple validation. Which will basically check if the property we're trying to set is the password property, and if the value supplied is less than 8. And if those two conditions are true, we'll throw a new range error, but if not, we'll actually assign the value to the property of the object. You'll also notice that the set trap has to return a value of true or false, just to let the proxy know if the set operation, or rather the assignment operation, was successful or not. So now if we try and assign a value to the password, you'll see in the output on the right hand side we're actually getting that range error because the conditions in the if statement inside the set trap has failed, but if we make our password a little longer, you can see the password property on the proxied user object gets set successfully. So that's just a quick introduction to proxies in ES6, and as you can see the set traps are quite useful for validation or value correction, whereas get traps are quite useful for extending the property lookup of an object, and there are some other traps available when you're working with iterable objects. In this tutorial, we're going to take a look at the reflect object that was introduced in ES6, and how you can use its metaprogramming properties to examine and analyse your existing code. So the reflect object is a bit strange as it doesn't really introduce any new features into JavaScript. However, what it does do is group together some of the more common operations to do with metaprogramming into a single API which you can use to analyse your code. So in this video, we won't deep dive into metaprogramming, we'll just take a quick look at some of the functions that are available with the reflect object. So with our example user object that we have here, we might want to add new properties at some point. And you'll be familiar with adding new properties using the dot or bracket notation. But there is also a define property function that's available on the global object. But you'll notice from the output on the right hand side that the actual object is returned from that defined property function, which might not be that useful if we want to know whether the actual property was set up correctly. So instead we can use the parallel reflect.define property function, which will return a boolean value to let you know whether the property was set up correctly or not. So the value of that is that you don't need to wrap your code within a try-catch block in order to catch any errors that might occur when defining that property. Because you're dealing with a boolean value, you can just use an if statement to do something differently if there's a problem. This also works in a similar way if you want to delete a property. For example, you'll be familiar with the delete keyword in terms of removing a property from an object. But you can also swap this out for the reflect.delete property function. There are also some other similar functions built into the reflect object that mimic keywords in JavaScript. For example, instead of using the in operator, you can use the reflect.has function to achieve the same effect. So as I mentioned at the start of the video, the reflect object is a bit of a strange one, as all it's really doing is bringing together a lot of the existing functionality in JavaScript in order to bring the functionality of metaprogramming into one single API. In this tutorial, we're going to look at promises in JavaScript and how you can use them to deal with sequencing in your asynchronous JavaScript code. So we'll first look at what promises are, how to create them and use them, and then we'll take a look at a few examples of how they solve problems with asynchronous JavaScript code. So a promise object intends to give you either a success or a failure after it's completed some task that potentially might take some time to complete. So when creating a new promise, you actually pass one argument to it, which is a function, which itself has two arguments, resolve and reject. So if we just examine the promise that we've just created, you can see from the output on the right hand side that it's in a pending state. That means we're still waiting for the promise to complete with either a success or a failure. And we need to set up some next steps to deal with those successes and failures in a similar way that we would if we were creating an event listener within our browser. So for a success, there's a property on the promise object called then, which again takes another function as an argument, which gives us any data that's passed back from the promise if it's successful, and there's also a catch property, which will also receive any data that's passed back if the promise fails. So you'll notice we've got no output whatsoever at the moment, so within our promise we need to indicate whether or not we have a success or a failure. And we do that using the resolve and the reject parameters that are inside our promise, and they are actually both functions, so we can use those to trigger either a success or a failure. So in this case, we're actually triggering the function on the then property, and just to prove that, we'll prefix the result. And as you might expect, if the promise was to fail, we can use the reject function. So in reality, we wouldn't just return resolve or reject without first doing some asynchronous task, which might be a network or file operation, but let's just simulate that with a set timeout. And you'll notice now when the code runs again, there's a slight delay before the then block is triggered, as we're waiting for the set timeout to complete before the resolve function is called. So let's have a look at how you might use a promise with a simple example. So here we have a simple asynchronous function that returns a random number after a certain delay, which in reality could be a network file or any other asynchronous operation. So if we log something out to the console before we call this function, obviously that string we're logging to the console is displayed first. So if you wanted to display the string after the number has been generated, you could conceivably put that inside of the async function, but to separate our concerns and to keep things tidy, we can put the console.log inside of a then statement. And because we have the result from the resolve function, we can display that first, or at least make use of that data, before our initial console.log. And of course, if there is any problem with the data from the asynchronous operation, we can always call the reject function. So just by using the simple pattern of resolving or rejecting based on good or bad data, you can effectively control the output and operation of your asynchronous code. So there are also a few static properties that are available on the promise object. For example, you might want to call several promises at the same time. For example, with our simple function, we can generate 3 random numbers, and you pass those calls to the asynchronous function into the promise.all static function, and then you can still access the then property to see the data that's returned. And also the catch property if there are any errors. The only caveat with the promise.all function is that if one of those asynchronous operations does fail, it will actually stop you getting the results from the other ones as well. So let's just remove the reject from the function. So now you can see in our then block that we have an array of random numbers that are generated by those 3 asynchronous functions. So this might be useful if you're sending multiple network requests to different sources, and you want to send all of those requests at the same time, and access the result of those 3 functions in the then property of the promise.all function. Finally, there is also a promise.race function available, which, as the name suggests, will actually return the data from the promise that finishes first. So running that a few times, you can see the random value that's the smallest, which is used as the set timeout delay, is actually the one that's returned from the promise.race function. So that could be useful if you have data from multiple sources that you're accessing, and once you've returned a value from one source, you can disregard any data that's returned from any additional sources. So when we looked at the module tutorial within our ES6 Essentials course, we talked briefly about transpiling, which is basically the process of taking your ES6 or later code and making sure it will run in other environments, such as older browsers. And we took a brief look at how to do that in the modules tutorial, but let's revisit that now using a tool called Babel, which is probably one of the most common tools to transpile ES6 code. So we'll set up a quick project that will allow us to write ES6 code and transpile it into an older version. And if you do head over to the Babel website, you can go to the setup section, select the framework or technology that you're working with, and you'll get instructions on how to set it up. For example, in this tutorial, we'll set up the CLI, which will be sufficient if you're working on a simple web project. So over in Visual Studio Code, I'm going to set up a new npm project. And I'm also going to install the Babel core, Babel CLI, and Babel preset packages. With those installed, we create a Babel configuration file to specify to use the preset package that we just installed. And let's just create a file with a bit of ES6 code in it. So actually installing those node packages gives us an executable which will transpile our app.js file. And the Babel program needs to know a file or group of files to transpile, so we'll specify a directory called out. So let's take a look at the code that Babel's generated for us, which, if you compare the original and the output side by side, you'll see a lot of the key ES6 features that we've been learning about, such as constant variables, default parameters, and template literals, have all been replaced with ES5 equivalents. So this will allow us to write source code in ES6 and create output files that can be distributed and used in environments that don't support ES6. So you can also add the Babel command into your package.json file, which will allow you to run the command with npm run. The only thing you will need to be wary of is working with modules, as you'll need a bundler like Webpack or Parcel in order to make sure all of the module names are resolved. But take a look back at the modules tutorial in this series for a quick overview on getting your code bundled together. So that brings us to an end to our ES6 Essentials training course. If you're thinking, where do I go next, or how do I keep up to date with the changes to ECMAScript, then you can take a look at the ECMA International website, where you can get a broad overview of the language and the changes that are constantly evolving, which form part of the JavaScript language. If you take a look at the link to the GitHub repository that they provide for you, you'll see that there are links to different proposals for changes to the language that are at various stages of being approved and implemented. So whilst this will give you a broad overview of the features that are in progress or have already been implemented, probably your best bet is to keep up to date with the latest blog posts, news and training videos that will give you a rundown on any major changes and key things that you should be aware of in your JavaScript code. So that's it for the ES6 Essentials training course. I hope you've gained some insight into the changes of ES6 and how you can make use of them in your modern JavaScript code.